Hello everyone, welcome to the next lecture on this numerical analysis. Today we will describe the method for root finding. The first method is called as the bisection method. We will explain you by the help of graphical and with the help of several examples. Myself, Dr. Harish Garg. You can simply follow my YouTube channel for finding the various videos on numerical analysis. So what is the table of content is? We will see firstly what is the algebraic and the transcendental functions and the equations. What is the root of the equations? What is the meaning of the root of the equation? How we can find the root of the equations? What are the various methods like as I mentioned here? And finally we can describe the first method with the help of the several examples. So whenever we are talking about the science and engineering, the system, or you can say the equation f of x is equal to 0, our primary task is to find the value of the x which satisfied this equation. That is, our target is to find the root of the equation. For example, if I say my equation will be here, then you can easily find the root of the equation. Like if I substitute x is 1, the answer will be 0. When you take x is equal to 2, the answer is a 0. So these are called as the root of this equation. So the purpose of defining the root is one of the most important tasks. Here the f of x may be the algebraic function or the transcendental function. What is the meaning of these two kind of the function? Any function y is equal to fx is said to be algebraic if you can write this f of x in terms of the polynomial. If you write any of the function in terms of the polynomial like x square plus x plus 1, x square minus 3x plus 7 by 4, this is a polynomial function. So, or you can say if you write f of x in terms of here where fi's are my ith order polynomial. For example, here you can see this is a polynomial, so this is the algebraic equation. This is the polynomial algebraic equation. A constant function like or a linear equation 2x plus 3 y is equal to 4, all are my algebraic functions. On the other hand, a non-algebraic equation is called as the transcendental equations. For example, you can say if f of x is not written in the form of the polynomials, it means if you express the function in terms of the trigonometric, logarithm, exponential, etc., then we call as the transcendental equations. For example, here this exponential function, this is a tan, logarithm, and so on. So this equation is called as, all these equations are called as transcendental equation. If I provide you one more example, like say this is a x square minus x ln of 2 plus e is equal to 0. Whether this is the algebraic or transcendental, you can see ln of 2 is a constant number. Fine. This exponential is again a constant number. We all know it's a 2.718. So basically it's a polynomial. So this means it is my algebraic equation. Although it's a present of the ln of this, that is a log of 2, natural log, but it is of the constant kind. So this is the algebraic equation, not for the transcendental equation. Next thing is how you can find the root of the f of x. So if you find the process of finding the root of this, that is you have to find the value of the x such that f of x is 0 is called as the solution of this, and the value of the x is called as the root of this equation. Graphically, if you have the function of this what is the meaning of the root is? It is a value of the x where the graph of y is equal to fx cut the x-axis at this point. So this is called as the root of the equation. As I described the transcendental equation, so it may have a finite or infinite number of the real roots, or it may not have any of the real roots. So it means we first need to know under what conditions the real root may existence. Like if you have the equation x square plus 1 is 0, so it is algebraic equation. So we all know it has no real root. The roots are only iota, plus minus iota, you can say, but that is not the real root. So it means our target is to find the real root. How you find the roots of the equations? So there are the two ways. One is the direct method, second is the indirect method. This is also called as indirect method. Fine. So once you have the direct method, like you all know, it is mostly applicable for the algebraic equations. Like if you have this quadratic equation, how you can find the root of this equation? We can apply the discriminant rule, that is a minus b plus minus b square minus 4ac over 2a. Then you can find the roots as here. So there are the two roots. On the other hand, This is the exact root. You always find the exact root by using this direct method. On the other hand, if you have the equation like of cos x is equal to x e raised to power x, then you are unable to find the discriminant rule, you are unable to find this by the direct method. Then we are able to find the approximate root of this function. So once we are talking about the approximate root, it means it has some accuracy, it has some error. So we have to find some root like say 10 raised to power minus 7 accuracy, 10 raised to power minus 3 accuracy, and so on. So that means we have acquired up to some desired accuracy. So how you can solve this indirect method? We can start with some initial guess and then we can improve it by the successive iterations. And once we can find some initial guess, say x0, we can find the new value x1, we can find the value of the new value x2, and we can so on. We can until we will get some desired accuracy. How you can make the accuracy? That means we have to apply some stopping criteria. That stopping criteria is based on either the absolute error or a relative error. So we all know how you can define the absolute error. This is called as the absolute error, this is called as the relative error, and this is called as the function value. So that is f of x. So these two methods are absolutely fine for working on the stopping criteria. But once you are working on this third condition, that may be misleading you. What is the meaning of the misleading is, it may possible that you can find the value of the x so that f of x is less than of some epsilon, say 10 raised to power minus 7, but that x is not closer to the actual root of the equation. So in that case, what is the meaning of that? When you have the x, when you approximate to the small x, it means the exact value is my x, you find the capital X, when you approximate them up to the n decimal places, then this is the absolute error. So the absolute error will be less than of half into 10 raised to power minus n, where n is the number of the decimal places. So it means if I want to calculate the result up to the 3 decimal places, then our error, then this epsilon must be of half 10 raised to power minus 3 must be there. Now there are the several methods for finding the roots of the equation in the indirect method. First one is the bisection, also called as the Bolzano and the interval halving, regular falsies, secant method, iterative method, Newton-Raphson method. In this lecture we are trying to explain you firstly the bisection method. In all these methods, the principle of finding the root of the equation is dependent upon the intermediate value theorem. In short form, I call as the IVT. What is the intermediate value theorem is? If you have the function f of x, which is a real valued and continuous function on the closed interval a comma b, such that the f of a and f of b, it means you have to find the function value at these endpoints, and if you find the product of them, it must be less than of the 0. Then there exists at least one real root. There exists one real root, and such that f of x will be 0. Make sure there is a at least. Fine, there is at least. So what will be the maximum is? It can be the infinite many roots, but it is always of the odd numbers. That means if we are talking about the at least one root, but it cannot be 2. Why? Because it's a 2 is an even number. So what is the meaning of that? I will explain you graphically. So what is the meaning of that? If you have the product is less than 0, what is the meaning? One of them is greater than, other one is less than. If this will happen, what is the graphical representation? F of a is my positive, so it means high. So this is my root. So if I take, this is my a, this is my b, if this is my positive, this is my negative, so either your graph will be look like say this, and at this. So how many solutions are there? You can see there is a 1, there is a 2, there is a 3, there is a 4, there is a 5. 5 is my odd number. But if you look about here, if this is my positive, this is my negative, can it be the even numbers like of this? It is a 1, it's a 2. It is not possible because you have to come back at this point. So definitely it must have a odd number of the roots. So that's why I'm here talking about at least one root is always be of the odd number of the roots are. So now once you have this, either this case or if this is a negative, then you have to start from here and this is called as the root of the equation. Now the question arises is how we can find this exact root of the equations. So for that we are trying to explain you firstly the bisection method. So this method is also called as the interval halving or the Bolzano method. Remember, this method is always give you the approximate solution, not the exact solution, because this is my indirect method. So once you are working on the indirect method, we always finding the approximate roots up to some desired accuracy. So what is that method? So what is the bisection method? If you have the function f of x, which is the continuous, and satisfy the intermediate value theorem, that is the f of here, then either f of a is my greater than 0 and f of b is my less than 0, so that this property is satisfied, or this property holds. So I can take any one of them. Let's start with this. So then the bisection method will approximate the real roots by taking the midpoint of the solution. What is the meaning? If this is my a, this is my b, f of a is my negative, f of b is my positive, so the graph of the function will look like, say, here. Fine. So this is my exact root. How you find that? So this is my a comma b. I can take the midpoint of this. This is the a plus b by 2 here. This is my initial x naught solution. So at this point you can see the function value is positive. Then again take the midpoint of the a and x naught. So say this value is here. So this is, say, my x1, and this point is my negative. Then take the midpoint of the x1 and x naught here. So this is my here, and so on. And then we can find this. We can take the midpoint of the x1 and x2 until we will get a closer root of this true solution. That's the principle of this bisection method. That's why we call it as the midpoint of this interval. What is that? We simply apply the 3-step rule. The first step is for the interval a comma b, we will find the first solution as a plus b by 2. Second step is we can find the value of this xk, whatever the function you have, and then check whether this xk is either a greater than 0 or is a less than 0. If it is a greater than 0, then we can resemblance with the b. If it is a less than 0, then we can resemblance with the a. That means if we find this f of xk, whatever the solution we have found, if this is a greater than 0, that means we are resemblance with a b. Then the interval we have to replace this b with the new solution xk, and that is we can set b as xk. On the other hand, if my solution is my less than 0, that means we have to replace the a. We have to replace the a with the xk. Then the interval will be my xk comma b. Fine. Then will be here. Now again we will get the interval. Again we will get the new point. Say x is a plus xk divided by 2 in this case, and in this case we will find the xk plus b over 2, and then we will check whether the consecutive difference between the two roots is less than of the epsilon or not. If it is there, then this is my root and stop. Otherwise we can move on this step by taking that interval. So where epsilon is my desired accuracy, it can be of 10 to the power minus 3. We can find the decimal up to the 3 decimal places, 4 decimal places, and so on. So since it is a iterative process, so we may take infinite number of these steps. So can you find in advance that how many iterations we needed to get the accuracy of this? This you can find it in advance. So since this method will take the midpoint of this interval, so the first interval is a and b, that is the first interval. Second is my this plus this over 2, and so on. So that means we are dividing the interval into the half side. So if I take this as a comma b, what is the length of this? B minus a. We find this new interval, say x naught, a plus b over 2. That means we are dividing the interval into the two equal parts. This is my first part, this is my second part. So this part is my half of the length, and when you are moving on the nth step, then we have the interval of the nth here. Can you find the value of the n from here? Yes, you can easily find that, which is written here. You can take the logarithm to the base 2 on the both side, which is my here. So this is the value of the n which you can find from here. So that means if you know the value of the A, you know the value of the B, you know the value of the desired accuracy, then you can find the value of the n as here. So that means you need at least this much number of the iterations in order to get this accuracy. What are the properties of the bisection method? This will give you only the real roots. If f is not continuous, then the bisection method will fail. If f is a continuous but it does not cut the x-axis, like of this example, if you draw the graph of this, it will be here. You can see it is not cut on the x-axis, so you are again the bisection method will fail because you are unable to find the real root of this equation. And we all know what is the roots of this equation is, that is iota. Plus minus iota is the root of equation. Bisection method always converges. Once once you know it is a convergence, then it is always be convergent. So look at that. We will explain you the 7 to 8 examples so that you are able to understand. Very simple method. So first of all, I consider this is my algebraic equations. So find the real root of this algebraic equation. F of x is 8x cubed minus 2x minus 1 up to the accuracy of this. So this is my epsilon here, bisection. So how you can apply the bisection method? You firstly find the value of the f of a and f of b which is less than of the 0. Clearly say that there is no interval given to you. Is the interval is given to you? No. So you can assume the interval by own. What is that? For example, if I take f of 0, what is the value of the f of 0 is? Negative, which is less than 0. Can you find another point whose value is greater than 0? Then I can say one function is f of a, second is f of b. So what is that? 1. What is the value of the f of 1 is? 8 minus 2 minus 1, that is my 5, which is greater than 0. So it means you can find the point a and b so that this will be satisfied. That is intermediate value theorem property satisfied. Fine. Now you can see here. So what is the meaning of that? The roots lies between 0 and 1. If you look at the graphically, f of 0 is my minus 1, f of 1 is my 5. So graph will be look like here. So this value is lies between 0 and 1. So my target is to find this one. So now we are applying the bisection method. So therefore a is my 0, b is my 1. Why? Because the interval is my here. So how you can find that? First of all, you can see how many iteration you needed in order to get this bisection method. So accuracy is my here. So what is the meaning of that? B my absolute error. Absolute error is my difference between the two is my. How many steps you needed? You can start with this definition. That is a log of b minus a here. We can substitute this value. What is the b? B is my 2. Oh sorry, b is my 1. A is my 0. What is the epsilon? This is the accuracy. So 10 raised to the power minus of 2 divided by log of 10 2. Now based on the calculation you can see log of 1 is 0. This is my plus of 2 log of 10 to the base of this divided by here. So this value will be 1. So it is 2 divided by log of 10 2. So now you can find this by using the calculator. You will get this as the answer. So that means n is greater than equal to 6.6430. So what is the meaning of that? The minimum number of the iterations you needed as a 7. Fine, because it's a greater than equal to here. So it means you need a 7 iterations so that you can get your answers in this here. That's the minimum number of this. Now how you can do that? A very simple approach, a very simple approach. I can tell you, you can draw this table. Fine. Look at this. First interval is my here. This is A. This is my B. Fine. Look at the value of the A. What is the value of the f of A is negative. You can take this as a negative, this as a positive. This is only for your own convenience. Fine. Find this value. What is that? A plus B by 2? 0.5. Find f of x. This is my f of x. Find the value of f of x at the point 0.5. So this value will be 8 0.5 cube minus 2 into 0.5 minus 1. So this will be 1 minus 1 minus 1. It is minus of 1. Fine. This will be here. Now since it is the first step, so there is no previous iteration, so error is my here. Now what you can do is that look at the sign of this. It is a negative. Fine. So what you can do, you can see here negative. So you can replace the negative value. This is a negative. You can replace this negative value with the help of here. Fine. If it is a negative, then you can replace the negative value. This value will remain the same. So you can see here, because this number is negative, you can replace the negative. Now find the a plus b by 2. Now this is the a, this is the b. So what is the midpoint of this? 0.75. Find the value of this at here. You will get this as this number. And what is the error is? You can see x0 minus x1. What is the difference between them is 0.25. You can see this is a positive value. So you can replace this value as here. This is my positive. You can keep the preserve the negative. Now once you know the a and b, you can find this midpoint value by using the calculator again. You will get 0.625. Find the value of this as here. And what is that? You can see the x3 minus x2. Difference between them is here in the absolute. Again you can see it's a negative number. You can replace this number as of this negative. The first, this number is as such. Now take the average of this. You will get this number. Substitute this value. You will get here. Again you can see this difference is not be less. What is the meaning of that? 0.01. It is not less than of 0.01. So we can find the next step. This is a positive value. So I can replace this number as here, this value as such. We can find this number. What is the difference of them? This here. Again you can see this is not less than of 0.01. Then we can move on this next step. This is a negative number. So we can replace this number as here and this positive number as preserved. Fine. Again you can see this number is not less than of the 0.01. So we can find this another number. Since this is a positive number, so we can preserve this number as such and this number as positive. Because this is my positive, so I have to replace this as positive. Now clearly says that this number is less than of this. So we can stop the process and this is my exact answer of this here. So the root with the desired accuracy is the required answer. So this is the way you can solve this bisection method. We will see more examples so that you can understand it very clearly. Use the bisection method. Now in this case interval is already given to you. So that means a is my 1, b is my 2 and this is my epsilon. Fine. In other words, this question can also be asked in this manner. That is, using the bisection method, find the point of intersection of the curve y is equal to 3x and y is equal to ex in the interval of this. I can write this because both are y, so I can return this number as here, which is similar of this. Now since interval is already given to you, so there is no need to find f of a and f of b, but we will check the f of 1 is a positive, f of 2 is a negative. Fine. So it means the root lies between 1 and 2. So we can start with the table. A, that is my 1, b is my 2. The value of the f of 1 is positive, so I can take this as a positive. F of 2 is a negative, so I can consider this as a negative. Fine. And my needed of the 10 raised power 0.1. So what is that? This is 1.5. I can substitute 1.5 here because this equation is called as the tangential equation. So I can substitute this value here. So this is because this is the first step, there is no error. Now you can see this value is my positive. So I can replace this value at the positive points. Now you can see this is my positive. So I can replace this value positive, this value as such. Fine. Now what is the midpoint of this? You can see it's a 3.5. So it's a 1.75 is the midpoint. Once you take substitute here, you will get this as the right answer. And you can see the difference of my 0.25. How many steps you are needed until you can find the next value? Check whether this is not less than of the 0.01. We can find here. Otherwise, what is the simplest shortcut trick is how many steps you needed. Otherwise, you can find this by using log of b minus a, log of epsilon divided by log of 2 to the base 10. You can find this is my a, this is my b, epsilon is here. You can find it. Otherwise, there is no need to find it. I will tell you the very simplest shortcut trick. You can, because this is a bisection method, so it will working divided by 2. So you can divide by 2. This is 0.25. which is not less than of this, we can find the next value 0.0265. Again, which is not less than of the 0.1, we can find the next value. Again, this is not less than of this, we can find the next value, which is 1.5, and so on. You can see at this point it is less than of this. So how many steps you are needed? You needed the 7 steps are there. Otherwise you can find from here, again you will get as 6 point something. That means minimum you need a 7 iterations are. That's on totally on your choice. Now how you can, now the rest of the part is very simple. You can see it's a negative, so I can replace this number with a negative sign. So this is my 1.75, this is my as such. You can find the midpoint, you will get here. Now this is it. Otherwise how you can find the error? You can see the difference of them, which is also similar of this. Since it's a negative number, you can replace this negative with this new value, and I can preserve this value. Take the midpoint of this, we can again get a negative number. You can see the difference of this is my here. Again it's a negative number, so I can replace this number with a negative. I can replace this number here, and this number is as such. We can find here. Again you can see it's a negative number, so this number is my here corresponding to a negative. This number I can preserve this one. Fine. Again this is a negative number, we can preserve, we can replace the B and preserve the value of A. Now you can see this error is less than of the 0.01. So we can see the right answer of this problem is my 1.50782 is the right answer. Okay, now look at this next question. Again this is the tangential equation. Now you can see the difference between this question and the previous question. In the previous question it is already given to you the error is 10 to the power minus 2. But in this question it is not given. But it is given that up to the 3 decimal places. So what is my absolute error? As I told you, what is the absolute error is half into 10 to the power minus n. Fine. So we can firstly find the error from here. This is my fx. Interval is not given to you. You can find the value of the f of a. You can find the value of the f of b, so that one is a positive, other is a negative. Either this is negative or this is positive. So how you can see, clearly says that what is the f of 0? Sine 0 is 0. So it is my minus 1, which is less than 0. Fine. But make sure whenever you want to calculate this here, you make this angle in terms of the radian. You can use your scientific calculator and set angle as a radian. Fine. So f of 0 is my minus 1. F of 0.5, what is the meaning of that is 4 e raised to power 0.5 sine of 0.5 minus of 1. Make sure this value is in the radian. Fine. So once you calculate them, you will get this number as a positive. So therefore the root lies between 0 and 0.5. So we can make the table. So error is half 10 raised to power minus of 3. So I can return this number as 0.5 into 10 raised to power minus 3, or 5 into 10 raised to power minus 4 is the required error. Now we can make the table. The first number is a, interval is 0, this is 0.5. The value of the 0 is my negative, so I can take on this as a negative. This number is my positive. Fine. Now you can complete this line here. Since this is a negative number, so we can replace this number with the negative side. So this number is my 0.5. So this number is my 0.375. Fine. So now once you know the error, how many iteration step you can find this? You can simply take the half of this. What is the half of this? 0.625, which is not less than of this. You can find the another half, again which is not less than of 5 into 10 raised to power minus 4. We can again find this, and so on. You can get up to here. This number is less than of this one. So you need a 10 iterations. Otherwise you can use the calculator also. You can use this formula, minus log of 10 epsilon divided by log of 2. Here this is my epsilon, b is my here, a is my this. Again you will get at least 10 iterations are here. Then how you can see, now you can see this is a positive number. We can replace this number on the positive side. Negative number we can preserve them. We can find the midpoint of this, we can get here. This is a negative number. We can replace this number at here, and I can preserve this number as such. This number is this number. You can find the midpoint again. You can here. Always use the scientific calculator. Again, this is a negative number. We can replace this number here and this number as such of this. This is a negative number. We can replace this number and preserve this number as such. We can find here. Again, this is a negative number. We can preserve this. This is a positive number. We can replace this number as a positive side, and we can keep this number as such. So we can see again this is a negative number, and here we can see now the last step is over. So this is the required answer up to this 3 decimal place. You can see also up to the 3 decimal places the result is match. So you can see up to the 3 decimal places you can round off them. The right answer is 0.371 is the right answer up to the 3 decimal places. Look at the next one. You have to perform the 5 equations. So there is no need of the error because you have to perform the 5 equations. So remember that again it's a sine and cosine. You have to set angle in the radian. Clearly says that when you take f of 0, it's a 0, cos of 0, 1 is a positive, f of 1 is negative. Root lies between 0 and 1. So now we need only the 5 equations. We can set here. 0 is a positive number. We can sign as a positive, 1 as a negative here. What is the midpoint is? 0.5. You can find the value of the 0.5 of this. You will get as f of x. There is no need to find the error because we performed the 5 equations only. Now this f of x is my positive. So I can replace this number with the positive value here. Negative number as such. Fine. We can find the midpoint 0.75. Substitute 0.75 in the given function. We can substitute here. Since this is a negative number, so we can change this value of the b. This is 0.75. This value as such. Again we can find the midpoint. We will get as a 0.625. This is a negative number. We can change this number as a negative here, and we can preserve this as a positive. Find the midpoint of this. We will get here. This is a negative number. We can change this number as here. We can preserve this number of this. So there is no need to find this. If you want to find, it's most welcome. And the right answer of this is my here, because we need to perform the 5 equations only. So this is the right answer of this problem. Look at one more example. Find the point of the intersection of this curve y is equal to x and y is equal to sine of 2x. So that is this is the point of the intersection. How you can find? We can firstly write the function in terms of here x minus 2 sine x, or you can also write this function as of this one. That's totally on your choice. And we need the accuracy of 10 raised to power minus 2. Since interval is not given, so how you can find the interval? So look at that. If I start from the 0, it's a 0. So we are unable to find it. So what is the f of 1? So if we start from the f of 1, this is the radian. Remember, this is in the radian. So this number is negative. F of 2 is a positive. Fine. Because remember, what is the f of 0? 0 minus 0, which is neither the less than 0 nor the greater than 0. So that's why we are working on the 1 and 2. Now we can start with the table. F of 1 is negative, so I can take the negative sign here. This number is my 1.5. I can substitute this value at here. So this number is 1.5 here, this number. Since this is a negative number, so I can replace this number with the negative side. So it's a 1.5, it's a 2. So this number is 1.75, a plus b by 2. We can find this number and here. So since how many equation we needed? Because this number is not less than of the 0.01, we can take 0.125, 0.625, which is again not less than of this. We can find the another number 0.125, which is not less than of this. We can find this again number 0.15625, which is again not less than. If you take this number 0.7 and so on, which is less than of the 0.1. So how many iterations you needed? 5, 6, 7 iterations you are needed. Remember, again you can find this again with the help of this formula. That's totally on your choice. This is over the log 2. Fine. So if you find this value, again you will get 6.6 something. That means you need minimum of 7 iterations. Now since this is a negative number, we can replace this value on the negative side. This is 1.75. This is my 2. Again this is a negative number. We can replace here and we can preserve the positive value. This is the positive number. We can keep this number as a positive and this number as such. Again this is a positive. We can replace this number as a positive side and we can preserve this number as here. This is a negative number. We can replace of this. So this is my final answer of this problem. 1.8984 is the required answer. Okay, look at this another one. Find the real root of this up to the accuracy here. Again we can see what is the f of 0, because it's a 0, it's a minus 1.2 which is less than 0. What is the f of 1? It's a 1. Log 1 is again 0. It is again negative. If you start with a 2, so it's a 2 log of 2 minus 1.2. It is my positive number, because if you multiply them you can see here f of 2 is a negative, f of 3 is a positive. So you can see the root lies between 2 and 3. Sorry, this number is my less than 0. If you start with the log of 2 calculation base 10, so root lies between 2 and 3. We need accuracy of this. We can start with the table. First number is my 2, 3, 2 is my negative, so I can take as a negative, 3 as a positive. Now it's a negative. You can replace that 2.5 as here. We can get this number. How many iterations we needed? We can find this number as decimal wise, which is not less than of 0.01. So we can find this iteration as here. We need again these 7 iterations, because this is a positive, so we can replace this number positive. This is a negative, we can replace this number as on the negative side and this number as such. Here you can see this number as this. This is my negative. I can replace this number as here. Value of this is my here and this number is my here, and so on. You can get after the answer of this problem as here. Look at this another one. Find the approximate value of this. So how you can find this f of x? That means your target is to return like of this. I can write this function as x cube minus 25 is equal to 0. Fine. So this is my f x cube minus 25. Fine. Now again the error accuracy is given to you. So can you find the function? This is my f of x is x cube minus 25. So clearly say f of 1 is minus 24, which is less than 0. What is the f of 2? It is 8 minus 25, which is again less than 0. What is the f of 3? It's a 27 minus 25. It's a 2, which is a positive. So you can see the smallest interval is my 2, 3. You may take as a 1, 3 as well, but the length is very large, so it may take more iterations. You can choose the as smallest as possible. You can also think about that. If you find the value of that 2.5, what is that 2.5 cube minus of 8? Check whether it's a less than 0 or not. So what is that 2.5 square minus is less than 0? Then you can see the root lies between 2.5 and 3. Fine. You may think about that f of 2.7. For example, if it is greater than 0, then the root lies between 2.5 and 2.7, because 2.5 is less than, 2.7 is greater than. So as smallest as possible you can choose the root, then it will be less iterations. So anyhow I can take as a root as a 2 and 3. So we can start from here. The value of that 2 is negative, so I can choose as a negative, 3 is positive. Now here is this number is negative, so I can replace this number as here. So we can find this number. Again this number is not less than of my desired accuracy. Okay, so we can find the third equation. We can calculate this as up to 7 iterations. So we can find this is a negative number. We can replace this number as here and so on. So based on this you can find this equation easily. You can see at the end of this you will get this as the required answer of this problem. Look at the one more example. So what is given to you? Sum of the two number is my 20. So let the two numbers are my x and y. So what is given to you? X plus y is my 20. Fine. If each number is added to the square root of this number, then the product of them is my 155.55. So these are my two equations given to you. Fine. Then you have to perform the 6 iterations of the bisection method. So firstly, you have to write in the function of the x. So I can find the value of the y from here. Y is my this. I can substitute the value of the y here. I can substitute the value of the y as here. Then what is my fx? I can return this number as minus is equal to 0. So you can see this is my fx. Now interval is not given to you. You can choose the two numbers such that one number is less than 0, other is greater than 0. So clearly say if you start with the f of 6, f of 7 which is less than and greater than 0. So this is my 6, this is my 7. 6 is my negative, 7 is my positive. And you need to perform the 6 iterations like it. So you can perform it as usual. Once you will perform this, at the end of the 6th iteration, this is my required answer of this problem. Fine. So once you know this is the value of the x, so how you can find the value of y? I can substitute the value of the x here. You will get y of this answer. So what are the two numbers? Two numbers are my this and these are my two answers. Look at one more example. How you can find the real root of this up to the 10 to the power minus 2. Again, very simple. You can start with f0, f1. So root lies between this, and you can try it by on. You can see up to the 7th equation you can get this root as here. So this is my required answer. You can try it yourself so that you can understand it easily manually. So I hope you can simply understand the bisection method through the various examples. We will see the next lecture on the regular falsy. Again we will see with the help of this table and easiest manner in our next lecture. Till then you can simply like, share and comment my video. Best of luck students. Happy learning.